So hello all, welcome back to our official 360DigiTMG YouTube page. And this is your Gen AI live session. And I'm your host Shilpa. We're going to continue. So previous sessions, we've seen a lot of Gen AI applications. I've given you live demonstrations. We've also seen how AWS can help out with your LLMs. What is a project life cycle of a Gen AI, etc. Now, today we're going to get into some important topic, which is vector database. Okay, I'll give you an introduction of these vector databases. What are the core concepts? What are some advanced topics? And they were hands-on. So probably we'll not be able to cover the entire vector database today. So I'll continue the remaining next session next Saturday, right? So let's try to understand what is a vector database. Why do we use these vector databases? What are the limitations, right? So basically, the traditional databases cannot handle the high dimensional data, high dimensional big data that we usually come across. That's the reason we use something called as vector databases. Okay, so we'll try to understand certain concepts and terminologies like what are vectors, what do you mean by vector spaces, what are embeddings, what are distance metrics, what are similarity measures, etc. Then we'll see a lot of applications of vector database as well. How do we search? How do we do a semantic search, image retrieval, music recommendation, all of these? How do we detect anomalies? How do we use this for clustering, machine learning, and personalization as well? Then we'll also look at a lot of core concepts. What are the different data structures, similarity searches? How do we do querying and filtering? What are modeling and embedding? So when you learn about vector representations, we'll also get into a lot of different models, right? How does fast text work? How does glove work? How does doc2vec work? Sentence, word, image embeddings, audio embeddings. So we need to first understand the basics of what is vector, vector space, and all that. Then we'll further move on to some advanced topics where we're doing machine learning integration, scalability, and performance. And we're also looking into some real world case studies where how these vector databases are used across different industries and how, especially in search engines and all of this. So we'll get a clear picture on that. And yes, definitely we'll do a hands-on lab. So we'll be working with the vector database and then we'll be building a search application with the vector database. Okay, so what exactly is a vector database, right? It is a specialized, it's a different special type of a database, which is specially designed in order to store a very high dimension data. So when you have a lot of rows, a lot of columns, high dimensional data, we are trying to store this kind of high dimensional data in the form of vectors. Okay, vectors are basically mathematical representation of a data point. Okay, for example, you have text documents, images, code snippets. Okay, all of these kind of data points. Okay, each element in that vector will correspond to a specific feature or attribute of the data. So we'll break down this huge chunky data into some sort of vectors, okay, wherein each vector is basically representing a particular feature or variable or attribute of that data. What exactly is a vector? Vector is like a mathematical quantity. Okay, vector will have both magnitude and direction. So often you visualize it as a directed line segment with arrow indicating the direction and length of the segment being represented by magnitude. So as we have all studied in mathematics, right, there are scalar quantities as well as vector quantities. So speed is a scalar quantity, whereas velocity, which also comes with magnitude and direction, becomes your vector quantity. Similarly, distance is a scalar quantity, whereas displacement, right, which also talks about direction, becomes your vector quantity. So these are what vectors are basically. So you take your entire content data, high dimensional data that you have, and you put it into an embedding model. And along with that, you give your application. What are you exactly looking for, right? Are you asking to summarize the text? Are you asking a query? Okay. Those kind of questions that you're giving through LLM, that is all fed into an embedding model. It will convert these vector embedding will happen. So it will convert all your data points into vectors, the heavy high dimensional data into vectors. And finally, it is stored within your vector database in the form of these small vectors. Okay. And from there, you get the result of your query. So within vector database, so basically you can see here, what happens is you have a huge text document, let's say, and this entire huge document is split into smaller chunks. Okay. Maybe sentences, huge paragraphs are broken down into certain smaller sentences. Maybe smaller sentences are also broken down into smaller words, etc. And according to these kind of sentences that it breaks down, okay, these chunks, these smaller chunks, are then used again to generate certain questions. Okay, wherein each question is answered by a particular chunk. All of this is put inside a vector database in the form of a vector. And what happens in retrieval is basically whenever a question is being asked by the user, what kind of books should I read, or what would a dog do? Okay, some sort of queries that you ask. All these queries are again converted into vectors, and they will search for the most similar question to your question and give the answer corresponding to that, right? It will bring back the chunk, the vector chunk, which is most similar answer to that. The retrieval chunk is then indexed by the question that it answers. Okay, so these kind of indexing is also done at the backend. So this is why do we use exactly this vector database? There are several compelling reasons to use a vector database instead of a traditional relational database. So we all know there is a lot of traditional relational database management systems like your MySQL, PostgreSQL, Microsoft SQL, you have Oracle database, IBM DB2, different relational databases that are present. Instead of using this, why exactly should I use a vector database? How does this vector database stand out, right? So when you're dealing with high dimensional data or tasks which involve a similarity or searching for similarity or searching for relevance, these kind of vector databases come into picture because it is splitting its data into chunks. Each chunk has a question attached to it. So that's how it becomes easier to retrieve relevant data. So first thing is efficient similarity search. Within vector databases, you can find similar data points based on their vector representation. You can fetch the similar data points. This is very crucial for semantic search, image retrieval, music recommendations, anomaly detection, and all of this. So traditional databases will struggle with such a huge task because they have a very rigid structure, right? And they do not support high dimensional data usually. So if you get into MySQL or PostgreSQL and all that, if you feed a high dimensional data, you will most likely, burden the server, overhead the server. So instead of that, and also there's a rigid structure that only this particular data type can enter. Okay, a lot of integrity is maintained to data. So these kind of databases can definitely not take up your, heavy data, high dimensional data, big data basically. So vector databases will leverage a lot of different algorithms like KNN, K nearest neighbors algorithm for searching and for cosine similarity in order to identify data points which are closest to the vector representation. So this will allow you to, accurately for whatever query is being asked, you can fetch the exact relevant information for that. So it helps out in basically enabling accurate and efficient retrieval of the relevant data, relevant information. Then obviously it can handle a lot of complex data. They're basically designed in order to store a huge number of data, which has a lot of features, a lot of variables, a lot of records. So it is meant to deal with big data. Okay, it's designed in such a way that big data can be handled within the vector databases. Vector database has the capacity or capability to sort of store and manage your high dimension data. It stores inside in the form of vectors. So that's how vector database works. It allows these high dimensional data to efficiently handle complex data, for example, like text document, images, audio files, scientific data sets. Even if you have unstructured data, it's going to handle it all. Okay, which are often difficult to represent in a traditional database schema. Obviously, audio files. So if you break down an image is nothing but each pixel, right? Divided into small boxes of pixels. And then each pixel will again have some numbering 0 to 255 or some pixels, right? So this kind of unstructured data, traditional database systems cannot really handle, and that's where vector databases come. So traditional databases extremely struggle with data containing many features, often leading to performance issues. So very limited speed and also limitations in expressing complex relationship between the data points. So it cannot really attach to a lot of different data points and all that. So it becomes a bit more complicated. That's the reason we switch over to vector databases. Then integrating it with AI and ML is quite easy. So vector databases are naturally going to fit the AI and machine learning applications because they have efficient storage and the way they retrieve is through vector embedding. So retrieval is also not a complex process. And this kind of simplified manner of retrieving data, storing the data efficiently, wherein the performance of your model is not getting compromised, is pretty crucial to, first of all, train the ML models, right? Because when you're training a machine learning model, good quality data, heavy data, the more data you feed in, the better results you get. So that's the reason switching over to vector databases was really helpful. So many vector databases will offer features like distance metrics, similarity search, okay, making these platforms very ideal for developing and deploying AI-powered applications. Definitely, you can have a lot of semantic features which search for similarities between the queries and all that. So obviously, integrating this with AI and ML becomes a cakewalk. Then, of course, scalability and performance. They're designed to scale for large data sets. Okay, they can handle a heavy workload, and because of this, because they can handle the massive amount of data, high dimensional data, you can use these vector databases for search engines, recommendation systems, fraud detection platforms, because the speed is also not compromised. Whereas when you look at traditional databases, they struggle with scalability and performance. When dealing with large data sets, you cannot really scale and all that. So you will end up with a bottleneck, and your processing will slow down to a great extent. So it will completely slow down the query responses. Then obviously flexibility and customization, because vector bases will offer a very flexible data models. You can index inside. So indexing always helps us to retrieve data efficiently, much faster manner. Then allowing you to adapt them to specific needs. You can define custom distance metrics and similarity measures based on our application. We can define what kind of requirements we have, what kind of data we're going to work with, right? Accordingly, you can change your vector database. Then traditional databases will basically have a very rigid structure, limited customization options, and this is going to basically sort of form a barrier, and it will mitigate your productivity when you're trying to do some complicated tasks. Yes, how was this distance between vectors calculated? So when I talk about similarity search, semantic search, right? Two data points which are lying close to each other are said to be similar. The more closer the data points lie, the more similar they are to each other. The more farther the data points lie, the more distance between two data points, the more they are dissimilar to each other. So how do I find out distance exactly between the vectors? And how do I calculate this distance, right? So vectors are used in vector databases because they will allow for efficient similarity search. This means that you can quickly find the data points which are similar to a given query, done by calculating distance between vectors. So to determine whether two vectors are similar to each other or not, I'm going to calculate distance between those data points. So there are a number of different distance measures that we have. You have Euclidean distance, Manhattan distance. Okay, a lot of different statistical distances available. But yes, most common one of them is Euclidean distance. Euclidean distance between two vectors is basically sum of square differences of the corresponding components. So I could say root of x1 minus x2 whole square plus y2 minus y1 whole square, something like that. So the Euclidean distance is a measure of how far apart the two vectors are in space. Smaller the distance, more similar these data points are, more similar the vectors are. Larger the distance, more dissimilar they are. So if I have a couple of vectors lying in a space, I can say that whichever pair lies closer to each other is the most similar pair. most similar data points, basically. So that's how you measure distance between vectors. Now, there can be some additional techniques in order to calculate this distance. So you have vector databases will use a number of different techniques in order to optimize similarity search. So different techniques can be there. Either you can use Euclidean distance, Manhattan distance, like I measured different statistical distances, or you can go for ANN search, which is approximate nearest neighbor search. ANN search algorithms will be able to find the approximate nearest neighbor, which are the data points that are closest to the query vector. Within a certain threshold, they will look for the closest data point, closest or most similar vector, I'd say. Right? Then you also have hierarchical navigable small words, HNSW graphs. These are basically a type of data structure which can be used for nearest neighbors in high dimension spaces. So if you're already working with high dimensional spaces, you can get the nearest neighbor using these hierarchical navigable small word, okay, graphs. Then you have product quantization. Now, this is a technique which can be used to quantize the vectors. That means they will be represented by some sort of smaller number bits. So these vectors are broken down into small bits, okay, small number of bits. And this makes it easier for you to search for the similarity in a faster way. So this could be one reason. So although you're doing it very fast, should be careful whether you're cutting back at the cost of accuracy. So that's for sure. So these are the three technical additional techniques for calculating distance. So first one could be Manhattan distance or Euclidean distance or any other popular distance measures, statistical distance measures, or approximate nearest neighbor search, ANN search algorithms, which will find you the nearest neighbor. Based within a certain threshold, it will go look for the nearest neighbor to the current corresponding vector. Then you have hierarchical navigable small world graphs, HNSW graphs, which are designed in such a way that they can find nearest neighbors in the high dimensional spaces. Then you have product quantization. They will basically quantize your vectors and they'll break down your one huge chunk of vector into smaller bits. And then it becomes easier to search for a similar vector, whichever is similar to your query or relevant information. What exactly is an embedding model? So within a vector database, an embedding model is a type of a machine learning model, ML model, which will convert raw data into vector representations. These vector representations will also be known as embeddings they are basically multidimensional arrays of numbers which will capture the meaning and context of the data. So embedding models will be trained on large amounts of space. And this means that the distance between two vectors in the embedding space is a measure of how similar data points they represent are. Then embedding models are used basically in vector databases for similarity search, okay, especially by storing data as embeddings. Vector database will quickly find the data points that are similar to a given vector. Okay, then yeah, these can be used to generate a lot of variety of data types. You can use text data, images data, audio data, video data, files. Okay. For example, word to vec embedding model can be used to generate vector representation of words, while a Siamese network embedding model can be used to generate vector representation of images. Okay. Embedding models are a powerful tool for building intelligence. Then it can also help you understand and respond to complex data. And because of these reasons, they become extremely popular. They become increasingly popular as the amount of unstructured data in the world will continue to grow. Obviously, we have a lot of unstructured data coming up: images, videos, music files. A lot of posts, text documents are always there. So these kind of unstructured data, how do you deal with it? It becomes a simpler manner because everything is given in a simpler manner. So this is vector embeddings. Conversion of data into vector evidence by embedding model. So in general, following guidelines can be used while choosing which model exactly we want to go for, which vector database we want to go for in order to embed. So for textual kind of data, we use this word to vec database embedding model or glove embedding model. Then for image kind of data, we definitely use CNN embedding model. Then for audio data, we will use a recurrent neural networks, RNN embedding models. Then video data, video is nothing but a broken down image, repeated again and again, right? So for video data, we use a 3D CNN embedding the model. If high accuracy, use a complex embedding model such as CME's network. So if you see any overfitting, high accuracy in the sense if you come across overfitting problem, then it's better to use your CME's network. Usually they'll suggest you to sort of rerun the code or something like that. So that's there. Then if computational resources are limited, use a simpler embedding model such as word to word. Obviously, if your system does not have that level of capacity to take in these advanced AI models like RNN, CNN, and all that, or CME's network for that matter, then it's better to stick with a computational sources which computational sources are limited. It's better to stick with a word to word kind of a database embedding model. Then conversion of data into vector embedding by these embedding models. So using these embedding models, we're going to convert our chunk of data, text data, document data into embeddings, vector embeddings. So you have audio. Audio is being converted into audio vector embeddings using the audio model. Then you can also have a separate text model, which allows you to convert it into text vector embeddings. You can also do it with probably videos, where again, video vectors embeddings will be available. So how is the raw data converted into a vector embedding in the first place, right? So the process of converting this raw data into vector embedding will involve vector database at any point. So basically, first step is to pre-process the raw data to make it suitable for embedding generation. This may involve cleaning of the data, removing noise, normalizing it. You finish all of these mundane data processing, data pre-processing, data organization, data cleaning tasks, and then we skip to the good part. So then comes your tokenization. In order for text data, the next steps will tokenize the text which is similar to units of measurement, such as words like words, phrases, okay, all of these things. Then rather than an entire document at once, probably tokenization would help. Then embedding generation. So embedding generation step is where the raw data is actually transformed into vectors. So this is typically done using a neural network model, such as word to vec and glove. And these models will be very trained on large corpus data, and they learn to represent words and phrases vectors in a high dimensional space. So if at all you're looking at text data, where you want to convert text data into vector embeddings, you can always go and contact word to vec or glove library, right? So these will help out in vector embeddings. Then we have dimensionality reduction. Vectors will generate the vectors generated in the previous step, which is in vector embeddings, are typically very high dimensional numbers. So they can be computationally expensive to store and manipulate at the end of the day. So we are going to reduce the dimensions. So you can see dimensionality reduction techniques such as principal component analysis. Then you can use you can reduce number of dimensions while preserving as much of information as possible. So that's there. Then comes your indexing, and one of the embeddings have been generated. Once the embeddings have been generated, they need to be indexed so they can be efficiently searched. So, like I said, indexing will solve half your problem of retrieval of data. It will basically directly impact on the efficiency of a thing and performance, the speed test. So that's the reason indexing was being taught. Then, such as tree-based indexes or inverted or indexes to optimize an e-similarity search. We have different industries. So that's how it works, right? So you can use indexing as well. Vector databases versus vector libraries. Okay. So what is the purpose of using this vector database, right? So specialized storage systems, basically, it's like a database. So it will be storing and maintaining data, especially for high dimensional data, unstructured data, bulky data like from your social media apps. So you can take bulky data from tweet, so from X, from Google, from Instagram, from YouTube. All of this have unstructured data and high dimensional data. So wherever they're storing the data becomes a more priority rather than using the data at the first place, right? So different vector database example could be Pinecone, Wilders, VV8, Vespa, OpenSearch, all of these are vector databases. Okay, some examples of vector databases. Then I also have libraries. So purpose of these libraries is they're standalone libraries which offer you how do we search vectors, similar vectors to each other functionally. So that becomes very easy when you're importing this particular library standalone, often integrated into existence applications or databases. Then examples of these kind of libraries would be FAISS, HNSWLIB, uh, ANNOY, then NMSLIB and SCAN. So these are some different libraries also which can help you with vectors. So what to choose, right? Do I choose a vector database or do I choose a library? So ideal vector database are basically ideal for production environments which have large and dynamic data sets and demand query performance. So for example, wherever you're talking about election polls, etc., heavy data coming in, large data, dynamic, keeps changing, there's uncertainty in that big data. So it's unstructured big data and it is keep on changing uncertainly. It's a real-time data. Then I choose vector database. Vector libraries, a little smaller scale. When the use case is more about research and integrating into a particular existing system, that is when you go for the libraries. So we discussed what are vector databases, what are libraries, how they are different from each other, how exactly these vectors are converted into embeddings. So how a raw data is converted into a vector embedding. Then conversion of data into this vector embeddings, how it does, etc. What is an embedding model, first of all? And how do I calculate distances between vectors? So how do I calculate distance between vectors and exactly why we should use vector database in the first place? And how vector database is going to help you integrate things with AI and ML. So we will go ahead next session and talk about each of these vector databases that we talked about, right? So different vector libraries, vector databases, what are the features, what are their limitations, how do we integrate, okay? All of these different vector databases we'll discuss in detail, and also vector libraries. So to do a quick recap again, we're basically trying to learn about vector databases because that is where you're going to store your data and train your model. From the data which is stored inside vector database, you're going to train your model and ultimately deploy your model also. That's the reason we're talking about vector databases. And we also looked into some terminology. What is a vector? What is indexing of a vector? What is retrieval? What is embedding model? Okay, why do we need to convert this raw data into embedding models? Why we need to do it and how to do it, using which models we can do it. Okay, exactly what is the process of converting? So you have data pre-processing followed by tokenization, then embedding generation, and then dimension reduction, and finally indexing so that it becomes easier for you to retrieve the data. And yes, you'll also find a lot of vector libraries. So when do we exactly use a vector database versus when do we use a vector library? Why there's a clear distinction between them. So we have drawn a very clear picture on that. So next session, we'll meet up on next Saturday and talk about these different examples that we have looked at, right? Vector database. So I've mentioned a couple of examples. We'll actually take a deep dive into these vector databases, each of these types of vector databases, and we'll talk about which vector database to choose, when to choose it, what are the limitations of each vector database, what could be the application, potential application, and how you can leverage these vector databases, right? So I'll stop this session here for today. And Thank you for tuning into our GenAI live session. And I think this is exactly where we're getting too technical now. So please take notes along with you and note down all the important information, different examples of vector database so that you can also explore after the session. So I'll meet you guys next Saturday. Until then, please take care and like, share, and subscribe. Please comment. We would love to get your feedback. So please like, share, and comment to our official webpage, official YouTube channel, 360digitmg.com. Thank you.